we have used the first initial condition to find the values of a sub n, and what we found was that this coefficient, this Fourier coefficient a sub 1 equals to 1, but the remaining Fourier coefficients equals to 0. The next step is to figure out the values of Bn. Now, to do that, we are going to use the second initial condition. So, basically the second initial condition says the derivative of your unknown with respect to the t at time t equals to 0. In other words, the initial velocity of the, let us say, this string equals to 0, or the wave equals to 0. Okay, so first thing first, let us find the partial derivative of this function with respect to the t variable. So, we have partial u over partial t equals to derivative of a summation equals to summation of the derivatives. Okay, now, we are differentiating with respect to the t variable. So, you should get a sub n, derivative of cosine is negative sine n pi t times n pi. So, we need to use the chain rule, plus b sub n times derivative of sine is cosine. So, we have cosine of n pi t times n pi, and then we have this function, but with respect to the t variable this is a constant. So, we have sine of n pi x. Okay, and if we evaluate this one at t equals 0, then should get, when t equals 0, here we are going to get sine of 0. Sine of 0 is 0, and then we are not going to get this first term at all. So, we have b sub n times n pi times cosine of 0 times sine n pi x, and our initial condition says this equals to 0. Okay. Let me simplify this. We have b n times n pi, and cosine of 0 is 1. So, we have b n times n pi times sine of n pi x exactly equals to 0. It means each of these coefficients b sub n must be 0. So, b sub n must be 0. Finally, we can update our function u. So, we have u of x comma t equals to, now we are not going to get this second term because every b sub n term must be equal to 0, and if you think about the first term, we are going to get only the term that corresponds to n equals 1. So, if n equals 1, you will get a1 equals to 1. So, 1 times cosine of n is 1. So, we have cosine of pi t times this term sine of, so now n equals to 1 sine of pi x. Okay. So, this is the solution of our original partial differential equation that satisfies both initial conditions as well as the boundary conditions. Okay. So, with this I finished the second example in my lecture notes, and okay, thank you.